So question 12 says, solve the following equation using a graphing calculator. So again, I have the equation 5x plus 3 is equal to 6. Now again, if I want to, I could just solve this by using the property of equality. I can get rid of the constant by using the zero pair, lose 3 on each side. So I would have then 5x equals 3. Don't like that. So 5x equals 3. Then I can make the 5 go away by dividing both sides by 5. So that turns the coefficient into a 1. So then I would have x equals 3/5. Now notice they want the answer as a decimal or an integer. So they don't want the answer as a fraction. So I could go ahead and just turn this into a decimal by going 3 divided by 5. And looks like I don't have to round. So the answer would just be 0.6. Now, what I could do though is using technology, I can actually use some graphing strategies. I could graph this a little bit. So there is an interesting thing on the calculator that you can do. So if I have this 5x plus 3 is equal to 6, one of the things we can do is set equal to 0. So what I can do is actually move the 6 to the other side of the equation to set to 0. So what I can do then is write this as 5x minus 3 is equal to 0. And what I can do is I can graph y equals 5x minus 3. And you can also graph y equals 0. So you can actually graph this equation. You can turn it into y equals 5x minus 3, and you can graph y equals 0. So what I can do is create these two equations. So what I'm looking for is what makes these two graphs what point do they have in common, if you will. So if I hit the y equals button, if I type in 5x minus 3, and then if I type in y equals 0, I can graph these. Now for you, the previous problem, if you did it, your scale is going to be all different. So you may have hit the zoom button. Number 6 actually resets your viewing window, because you remember the previous question, our viewing window, the y values especially were like 700 and negative 700 and things like that. So if I hit this Z standard, notice that if I go back to the window, notice that my window gets reset back to negative 10, 10, 1, negative 10, 10, 1. That's usually what if we're doing our math in this class, this viewing window really works for a lot of our problems. So if I graph these now, notice how I got these two graphs. My solution is actually where these two lines intersect. So how do I do this now once I grab them graphed? Notice right above the trace button, there's this little calculate. So notice that if I hit the second button and there's this calculate up there, it'll create a menu. So right above the trace button, notice how this is in blue. So you got to hit the blue button first, hit the trace button, but it actually does the calculate button. It creates a menu. Notice the number 5 is intersection. So if I use number 5 there, it'll kind of give us some breadcrumbs. First curve. So what that means is the first line, if you will. And if I hit enter, it'll go to the second curve. If I hit enter again, it'll take us to where they intersect at. So the intersection x equals 0.6. So that's what we're wanting is the x value here. Notice how we're solving for x. So x is 0.6, and that's what we found for x is 0.6. So we actually can use the graphing calculator. And one of the easiest ways to do it is just set the equation equal to 0, if you will. and then graph those two equations, if you will. And then where they intersect at, that x value is the solution to the equation. So this can be used for equations that are much more complicated in the real world, if we're using our TI-84. But again, there's other technologies out there as well to solve more complicated equations. But anyway, what they're showing you now is a hint that the intersection of two lines could actually be used to solve this equation by recreating this as two separate equations. So I'll leave it at that.